Hi everyone, my name is Edward, and I'm one of the UGTA for the course EEE335, and today I'm going to talk about pass gate logic and dynamic gate logic that could help you to finish your homework. So as you can see here, I have an AND gate and a OR gate logic shown here. I also have the truth table drawn down below, and let's talk about the AND gate first. So if B is 0, that means this part here, there's no connection at all. And if there's no connection, no matter what value A is, Y will always be 0. However, if B is 1, that means this connection here is connected. So then the value of Y will be depends on the value of A. So if A is 0, then Y will be 0. And if A is 1, then Y will be 1. And if you look at this truth table here, the NAND gate's logic has the same values as a regular Boolean logic truth table values. So same thing for the OR gate. So if B and C are 0, that means there's no connection at all. That means no matter what value A is, there's no way that it can pass through to Y. So therefore, if B and C are both 0, Y will be 0 no matter what. And if either B or C, it's 1, then we could look at the value of A and C and decide what value of Y will be. So let's say if B is 1, so we're looking at here, if B is 1 and A is 1, that means Y will be 1. And same thing, if C is 1, A is 1, then Y is 1. Of course, if both are 1, Y will be 1 as well. And same thing here, if you compare this with the regular OR gate truth table, you see the same thing. And that's how you read a pass gate logic. And let's talk about an example in the book, which is 1542. So in the book, it said, using the idea presented in figure 15.27, sketch a CPL circuit whose outputs are Y equal to AB prime plus A prime B and Y prime equal to AB plus A prime B prime. So the idea is that you want to read this diagram from the left to the right, top to bottom. So let's look at the first row. So we have A here passing into an NMOS with the gate value as B prime. That means at this point here, we have A, B prime. And for the second row, we have A prime going into an NMOS with B as the gate. So that means at this point here, we have A prime B. And since they're parallel, therefore Y is equal to A prime B plus A prime, so AB prime plus A prime B, which matches the first part. And for the second one, so for the third row, we have A prime going into B prime. So at this point, we have A prime, B prime. And for the last row, we have A going into here. So at this point, we have A, B. Therefore, Y prime it's equal to A prime B prime plus AB. Alright, so let's talk about the dynamic logic. For dynamic logic, it's pretty easy to recognize it because so if I first draw the static logic, so you have VDD and it's connected to the pull-up network, and you have the output, then you have the pull-down network and it's connected to the ground, and that's static. But for dynamic, you have the same thing down there. You have a ground connected to the pull-down network, the output. However, for the pull-up function instead, you have a clock that connected to the VDD. Therefore, if a Boolean expression is given, so for example, if they said y bar it's equal to A plus B and C. So when you were asked to draw this in with dynamic logic gate, what you should do is to first draw the pull-down network, like how you would do for static, and then for the pull-up network, which is the PMOS part, just draw a clock to it. So it could be something like that. So if I start with the pull-down network, so I have A plus B, which means A is parallel with B, and they are both NMOS. So for C, it gonna be on top of here, C, and that's the pull-down network. So you draw the function Y here, and for the pull-up network, instead of drawing the pull-up network, just draw a clock. That's the clock. And for now, I believe that you need to have a sense of how to understand the dynamic logic with respect to a Boolean expression. But in terms of the issues or the math part of dynamic logic, I think that you'll have to care more about it when you go into the EEE335 class, which is the digital circuit design class, probably in your senior year. So if you have any questions about this document or your homework, feel free to email me. I'm Edward, and thank you so much for your time.